Some differential equations have equilibrium solutions. These solutions have the form y equals c, where c is a constant. You can solve for equilibrium solutions either algebraically or graphically. Equilibrium solutions can be classified into one of three groups. Consider y equals k as an asymptote. What happens to our solution as x approaches infinity? If y approaches k as x approaches infinity, then y is an asymptotically stable solution. If y never approaches k as x approaches infinity, then y is an asymptotically unstable solution. If neither case is true, y is asymptotically semi-stable. We can solve for the equilibrium points with algebra. Consider the equation y prime equals the quantity y minus 1 squared times the quantity y squared minus 9. Note that we are given y of 0 equals 2. This factors out to y prime equals the quantity y minus 1 squared times the quantity y minus 3 times the quantity y plus 3. We can see here that we would have three values for which y prime is equal to 0. These will be the equilibrium solutions. Looking at the first part of our equation for y prime, we can see that when y is equal to 1, the expression becomes 0, which makes the whole equation equal to 0. Therefore, y equals 1 is an equilibrium point. Next, we have the expression y minus 3. In this case, if y equals 3, the whole equation becomes 0. So we know that y equals 3 is our second equilibrium point. Finally, we have the expression y plus 3. Here, we know that the equation will become 0 if y equals negative 3. Therefore, y equals negative 3 is our final equilibrium point. Now let's calculate the direction field for our example problem. The equilibrium solutions are where the slopes are 0 at a constant y. In other words, where the slopes are 0 for all values of x. This occurs at y equals 3, y equals 1, and y equals negative 3. Y equals 3 is an unstable solution. At all values of x, from either direction, the slope field points away from y equals 3. Y equals 1 is a semi-stable solution. When approaching from above, y approaches 1. When approaching from below, the slope field points away from y equals 1. Y equals negative 3 is a stable solution. At all values of x, from either direction, the slope field points toward y equals negative 3.